Good day, everyone. So today the topic that we're going to discuss about is the probability of mutually exclusive and not mutually exclusive events. So without further ado, let's dive into this topic. For our introduction, we're going to introduce you to compound events, mutually exclusive and not mutually exclusive. So, what is a compound event?
A compound event is made up of two or more simple events connected together by terms and or. It would either be an intersection or a union. It may happen at the same time or it could not at all. Mutually exclusive. If two events cannot occur at the same moment, they are usually mutually exclusive. These events have nothing in common. They are also known as disjoint events.
Example, rolling a number divisible by 2 or rolling a number that is multiple of 5. Drawing a red card or drawing a club.
Not mutually exclusive.
If two events can occur at the same moment, they are not mutually exclusive. These events have elements in common. They are also referred to as inclusive events.
Example, rolling a number divisible by 2 or rolling a number divisible by 3. Rolling a prime number or rolling an even number.
That's all for our introduction. Now we're going to talk about the probability of mutually exclusive and not mutually exclusive events.
Probability of mutually exclusive events. If two events, A and B, are mutually exclusive, the probability that either A or B will occur is equal to the sum of their probabilities in symbols.
The probability of A or B is equals to the probability of A in union with B is equals to probability of A plus the probability of B. In Venn diagram, circle A is separated with circle B because mutually exclusive events are events that cannot occur at the same time.
Example number 1. There are 6 white pebbles, 9 gray pebbles, and 3 black pebbles in a sack bag. Jose selects one pebble at random. What is the probability that the pebble is either gray or black?
So again, the pebble could not be both gray or black. So this is an example of a mutually exclusive events. So in order to find the probability of getting a gray or black pebble, we need to add the probability of getting a gray pebble and then we add the probability of getting a black pebble. So with this, we're going to have the probability of gray or black and it's equals to, but first we need to determine first the number of sample size. In order to determine the number of sample size, we need to add the total amount of pebbles, which is 6 plus 9 plus 3, and it's equals to 18. So, how many are there gray pebbles on the problem? There are 9 gray pebbles on the problem, so 9 over the total amount of pebbles, which is 18, plus the amount of black pebbles on the problem, which is 3 over the total amount of pebbles on the problem, which is 18, which leads us to 9 over 18 plus 3 over 18. So now, the probability of getting either gray or black pebble is equals to 9 plus 3 is equals to 12 over 18 or 2/3. Now, let's remember that our answer should always be in lowest term. So, the probability that the pebble is either gray or black is 2/3.
Example number 2. From a regular deck of 52 cards, one card is picked at random. What is the probability of either a queen, a 5, or a 4?
So, these three events are mutually exclusive events. In order to find the probability of drawing a queen, a 5, or a 4, we need to add the probability of a queen, probability of 5, and probability of 4. Queen, or a 5, or a 4, which is equals to the probability of getting a queen is equals to 4 over 52 plus the probability of getting a 5 is equals to 4 over 52 plus the probability of getting a 4 is equals to 4 over 52. So we're going to add the probability of getting a queen or 5 or 4, which is equals to 4 plus 4 plus 4 is equals to 12 over 52 or 3 over 13, which is the lowest term. So the probability of getting a queen or 5 or a 4 is 3 over 13.
Probability of not mutually exclusive events are inclusive events. For any two events, A and B, of the same experiment which are not mutually exclusive events, the probability of the union of A and B is
equals to probability of getting A plus probability of getting B minus probability of getting both A and B, which is the intersection of A and B.
And here is the illustration of the probability of not mutually exclusive events in a Venn diagram. Example number 3. Given a 45% chance of cloudiness on Monday, a 30% risk of heavy rain on Tuesday, and a 15% of heavy rain on Monday and Tuesday, what is the probability that it will rain on either Monday or Tuesday? So event A, it will rain in Monday, and event B will rain on Tuesday. So the probability on event A is 45%, and the probability on event B is 30%. And then A intersection of B, we have 15%. So now we're having the formula of the probability of getting A union B is equals to probability of A plus probability of B minus the probability of A intersection B. So now we're having the probability of getting A union B is equals to the probability of A is equals to 45% plus the probability of B, which is equals to 30%, minus the probability of A intersection B is equals to 15%. The probability of A union B is equals to 45% plus 30% minus 50% is equals to 60%. So the probability that it will rain on either Monday or Tuesday is equal to 60%. Example number 4. There are 13 teachers, 6 females and 7 males. A group of 5 instructors is chosen at random to attend a meeting. What is the probability that the group will include at least 3 females?
The probability of at least 3 females is equals to probability of 3 females plus 2 males plus the probability of 4 females plus 1 male plus the probability of 6 females plus 0 males. The probability of at least 3 females is equals to our n, 6, c, our r, 3, multiplied to 7, our n, c, our r, 2, all over our n, 13, c, our r, 5, plus our n, 6, c, our r, 4, multiplied to our n, 7, c, our r, 1, all over 13, our n, c, our r, 5, plus our n, 6, c, our r, 6, multiplied to our n, 7, c, our r, 0, all over our n, 13, c, our r, 5. The probability of at least 3 females is equals to 420 all over 1287 plus 105 all over 1287 plus 1 all over 1287. You add all of these with the same denominator. The probability of at least 3 females is equals to 526 all over 1287.
Thank you for listening, and I hope you learned something. And these are the group 5 members that participated in this video. Once again, thank you and goodbye.